welcome to MG Engineers Academy. In last session, we have discussed the problems related to First shifting theorem, and today we are going to have a discussion on property number 2. So, let's start it. Laplace transform. Today, we are going to learn property number 2 or multiplication by t. So, what we need to do here, if we have Laplace f of t is equal to a bar of s, then prove that Laplace t into f of t is equal to minus d by ds a bar of s. This we need to prove. So what we have given? We have given this f of Laplace f of t is equal to a bar of s, and we have to prove this. What we have to prove? Laplace of t into f of t is equal to minus d by ds a bar of s. So now be careful. Please give attention here. How we are going to discover this value answer. Let me show you. Now what I can do, I will take right hand side. What is right hand side? Minus d by ds a bar of, right? This is the right hand side. So now for f bar of s, I can write Laplace f of t because this is a given to us. So minus d by s into Laplace of f of t, right? I can I have mentioned here Laplace f of t because we have given the condition that Laplace f of t is equal to f bar of s. So we have f bar of s here, so that I have mentioned L of Laplace of f of t at this place. So next, now you know the equation of Laplace is Laplace f of t 2 is equal to integration 0 to infinity e raised to minus st f of t into dt, right? So I'm going to use this equation in this place, right? So what I can get, d by ds into integration 0 to infinity e raised to minus st f of t into dt, right, is equal to. So here we have get minus d by ds integration 0 to infinity e raised to minus st f of t dt. Now term, let me mark it. Okay. This is the differentiation, right? And this is the integration, right? So in one equation only, we have to differentiate and we have to integrate. So in order to differentiate, now what we have to differentiate? We have to differentiate d by ds means s with respect to s, because here we have term e raised to minus st. So we have to differentiate this exponential term e raised to minus st. But we cannot directly differentiate when we have integration in the place. So in order to differentiate the value inside this integration, we have to apply Leibniz rule. So I will mention here differentiating by differentiating integral by applying Leibniz rule. So what we can mention here, integration 0 to infinity. We have to differentiate e raised to minus st. So d by ds e raised to minus st. What is the differentiation now? So I will revise 11th and 12th standard, d by dx into e raised to x. So what is the value of this standard equation? E raised to x, right? Into differentiate of x is 1. So e raised to x. Similar way, here we have d by ds e raised to minus st. So if I use the same, then e raised to minus st, right? Now t is constant. Here we have to differentiate st as well. So differentiation of es will be 1 into t. So minus t, because here we have minus sign, into e raised to minus st. Sorry. Okay. So I will write e raised to minus st to minus t f of t dt, right? So next I will take minus t outside, 0 to infinity e raised to minus st f of t to dt. So here I have not mentioned minus sign because it's a minus here. So minus, a minus minus become plus t into 0 to infinity e raised to minus st of t into dt. So minus t into, at this place, what can I write? Laplace of t into, at this place, what can I write? Laplace of f of t, right? And This is the required t into Laplace of f of t, which is left hand side. You can see what is the left hand side here. Laplace of t into f of t, right? Either you can take t inside because it's a constant only. So no, there will be no any issue. Laplace t into f of t, right? And we have proved Laplace of t to f of t is equal to minus d by ds into f bar of s. So now in next session we are going to have problems based on this property number 2. So if you have any doubts or any need any clarification, so just comment me in the box so I can provide you more guidance on it. So see you in next session. Bye.